Hello. Good morning, everyone. Thanks for the introduction. Maybe I'll put my words to it. Unfortunately, I don't think I can call myself a surfer. My surfing experience goes in waves. Literally, I have one good summer where I can try to consider myself semi-decent at catching some waves, and then a few years go by, and then I have to start all over again. But it is in my to-do list to aspire to become part of this culture and more integrated into it. And the main reason is that I think, as with most things you do in life, you need some drive and some passion. There's always the cliche of if you do what you love, you never work a day in your life. And a question I've gotten, I think the most when I talk about my career is, how do you leave Formula One to join the wind industry? So as was mentioned in my introduction, I started my career as a Formula One engineer. It was super exciting. It's a sport of engineers. It's the best thing you can aspire to as an engineer. But the reality of it is that my first day at work, I would go to the race base and see how they were building the car and check everything out. And I just loved it. After 4 years, I just ran to my desk because I had too much work to do. And I didn't even care. It was just another day at the work, and you don't even look at what you're doing anymore. So, long story short, purpose is important. I've been in the wind industry now for just about 15 years, and I love it. I love it to bits. I think it's the future. I think it's the future of the planet. I think from the heart that it is things. And hopefully today I can give you a little bit of the reasons why. And I think in many ways it resonates with a lot of the things we'll talk about today, and with a lot of the elements that define the surf community. And maybe getting a little bit into it. Do you know how a wind turbine works, I guess? Right? Everyone's seen one. 3 blades, spinning, white, big thing. How does anyone, maybe a question more suited to you, how old is surfing as a sport or as a practice? 5,000, okay, good, thank you. We're not that old, but close. So harnessing the power of wind, it's something that has been going around for over 1,000 years. So, you hear a lot of things in the news, especially coming from the US administration. Harnessing wind is something that's been around for more than 1,000 years. This is a photo from my hometown in the center of Portugal. It's an old windmill that was used to power flowers. So we've been doing this for a really long time. So it begs the question, why are people complaining about it now if it's something we've been doing for so long? I'll share also an anecdote. I finished university in Lisbon around 25 years ago. And around that time, a colleague of mine did a study to try to locate, a very complicated computer study, to try to locate the best areas to put wind turbines in an area close to Ericeira that most of you will know, towards the interior, the area of Lourdes. And then she finished her study, a computer study with a map and the 3D area and the hills and everything. And then she decided to take a drive around there with her boyfriend. And all the sites that, through her very complicated and advanced study, all the sites that highlighted that was a good place to put a wind turbine, a modern electricity producing one, had one of these things in it. So people 1,000 years ago, through advanced science of doing this, could actually figure out what was the best location to put these things. So experience matters. But if you're willing to bear with me a bit, and to try to bring this close to the title of the session today, I'm going to get a bit technical about winds. I hope I can carry you through this journey, because in one of my first professional meetings, as was said in my introduction, and my very nice introduction, I found a calling on the wind industry, and I found another one, and that is bridging somewhere between an engineering world, the world of geeks that I've always felt comfortable with, the world of technical knowledge, with the world of business, which is two completely different languages. And my experience has shown me that there's not that many people that live in the two worlds, right? You're either a technical kind of expert, or you're a business mindset that don't care about the details that drag your business down and your initiatives down. And sitting somewhere in between, translating the two, has been something that I found a lot of fun. So 10 years ago, I went to the Canary Islands to discuss the possibility of us in Vestas. By the way, that's my company. I forgot to mention that. Maybe I should have started with that as an important point, given that we are a proud sponsor of this event. But I started in Vestas around 10 years ago, and we went to the Canary Islands. And I was there to present our technical portfolio of solutions to the customers. I had a very interesting presentation. And the head of the wind industry in the Canary Islands said, you guys need to put turbines in this area. And we said, okay, but we need to kind of quantify the wind. And he says, you don't need to. I've been windsurfing there for 20 years. I can guarantee the wind is good. And he was, again, the head of the Wind Industry Association. So we assumed he would know something about it. But he insisted, no, the wind is good. And we said, but how good? How do you know? And he goes, no, I've been windsurfing there my whole life. It's good. I said, okay, but there's a few things that we need to know beyond the fact that wind is good. You know, I guess you know on the experience side what good wind means much better than I do, given that you're sitting out there in the waves most days and you know how it helps shape the wave. I'm not going to presume knowing much about that or teaching you anything about that. But to a wind turbine, wind is our fuel, right? The same way that nuclear power fuels nuclear turbines, the same way that, you know, diesel will fuel a generator, we work based on wind. And what we do is harness the power of wind. What we've been doing for the last 50 years has been harnessing the power of wind with increasing efficiency, both in terms of cost and in terms of sustainability of our products. But we'll come to that in a second. When it comes to harnessing wind, a bit the same as when it comes to trying to understand what a wave is going to behave like, or what sail you should put on your wind kite or windsurf or whatever it is, you need to be able to gauge what that wind means. So if today we wanted to go and build a wind farm, we would have to look at all these things. Now this is going to get a bit technical, bear with me, I'll try to move quickly through it. The first thing we need is, because this doesn't work anymore, we actually need to go out and measure wind. So we use these things, a meteorological mast. It has a bunch of clever sensors that measure wind speed and temperature and variations in direction and things like that. And then we identify all these values. The one that you probably relate to the most is average wind. Average wind is basically what you say when you say there's a really windy day. For windsurfers, I don't know if any of you go into that discipline, then there's the Beaufort scale, which is very famous, also for someone that sails, that will tell you basically what kind of sails you need based on the wind conditions. For us, we don't really use this scale, but this is important because basically this tells us how much energy is in a wind on a specific site. And that's really important because that tells us how much energy we can capture, and ultimately to our customers, how much power they're going to produce, and of course, how much money they're going to make. But wind doesn't just behave like that, then it distributes statistically. The reason I wanted to talk about this very technical aspect of wind distributions is that wind has a behavior like all of us. And depending on where you are, wind will typically behave repetitively and follow some patterns. That means that you can also put a statistical distribution to it that says most time of the year, so 18% of the time of the year, wind will be blowing from a certain direction on a certain place. That's also how you start to understand when you have good days to go out to the beach and bad days. It's here in Porto, you'll know that there's a nortada coming, and it comes very frequently, because statistically, that's how wind behaves here. It does that in most of the world. Some clever people found out that wind behaves this way. It typically always blows from two directions the majority of the time. In the case of Denmark, where I lived for the last 6 years, there's a magic phenomenon that says that you always have a headwind, especially if you're cycling. That's why they have good cyclists and no mountains. Is that in Denmark, for some reason, when you're riding a bike, you always have a headwind. That's also because Denmark is such a good place for wind and has such a good wind. I mean, it's in the middle of the North Sea and it's completely flat. So it's undisturbed winds all around. And that's also why in the 70s, the clever folks in Denmark, with the oil crisis back then, realized that instead of buying oil, they could produce electricity from wind, and that would be cheaper. And that's how our journey started. But let's get a bit more technical. Then wind, as I'm sure you'll know, when you're at the beach, it feels like it's a lot windier than if you're in a forest, because the wind will increase with height, right? When you go up a mountain, it also feels way windier than when you're in a flat area. That's because, of course, wind behaves in a way that all the disturbances you have will reduce the wind speed. So here, right here, we'll have a lot more wind than you'll have if we're in the city center, because we've got buildings and trees and all the things. For us, this is important because that will dictate how high we need to make our turbines. You'll see that turbines sometimes are very high, others are very low. That's because wind changes with altitude. In the sea, that's not an issue. It's also interesting, for example, in Brazil, northeast Brazil, you have some of the best wind resource in the world to produce electricity. And that's because wind comes from the sea into land, and it's perfect wind all year round. It's fantastic for us. This one's not that relevant, but of course, the higher you go, the less air there is, the less air there is, the less energy we can produce. So of course, it's something that's important to us. And then the other two are complicated for us, because turbulence is what you get when, of course, when we talk about average wind, that's basically if I'm pushing you around in a skateboard, to use and I'm just pushing you smoothly around. The faster I push, the faster you'll go, or the more energy I use, the faster you'll go, and that's about it. Now imagine that at the same time that I'm pushing you smoothly around, I'm shaking you. That's basically what turbulence does to a wind turbine, to anything, right, to a wave. If wind is fluctuating a lot, then it's changing all the time, then of course it's going to impact on the short, very short periods of time. It's going to be kind of shaking things. And for us to design a turbine, that makes things a little bit complicated. Same thing with extreme events. When we have an extreme event, our turbines are super clever these days. So they know how to shut down and make themselves invisible to wind. But they need to be there when the storm passes. And that's also something that we need to design for. When you're in places like Taiwan or Japan where you have typhoons, then we need to design our turbines to guarantee that they're still there when the storm's gone and they can produce electricity again. Of course, because especially that's the time where people need it the most. They won't be able to produce electricity when these things are happening, but they need to survive. So that's 6 things, you know, for the wisdom of wind I talked about in the beginning. Now it's 6 very technical parameters that we need to understand and measure and quantify to provide a very technical solution. It gets deeper than this, right? And this is where it becomes super interesting for an engineer, is when you really want, and maybe this is why I'll never really be a good surfer, is because I try to analyze everything to the detail instead of feeling it or sensing it or getting my best gauge at it. I always try to understand what's happening behind. And I think the right word is overthinking. I overthink, and that's also why I've not been the best at most sports, is I overthink things a little bit too much. But at the same time, I think that made me a fairly decent engineer. Last thing, and this, I promise, is the last complicated slide I'll show you today. Our turbines produce winds with what we call a power curve. So when the wind starts going up, they'll start producing electricity. They get to the point where they reach the maximum that they can produce. And then when the wind is high enough to protect themselves, they start winding down. You join that with your average distribution of wind on any site, and that will tell you how much electricity you're going to produce. Now, we hear a lot that, of course, wind is fickle. It changes all the time. True, but we know when it changes, right? That's part of our work, is to understand when you have wind, how it's going to blow, because in the end, it's going to tell you how much energy you're going to produce. And of course, when you combine that with the electricity price in the market, it tells you how much money our customers will make, which is something that's fairly important for us as a business, because in the end, we need to sell our turbines so that our customers produce electricity and sell it in the market. Good. Are you still with me so far? Thank you. Good. The next part of our journey is, how have we made this work? When we started, I told you we started in the 70s, right? And Vestas was a company that made agricultural machines in Denmark. They were a bunch of good engineers that went into a shed and made machines that people needed. And as I said, the oil crisis in the 70s, they thought that making something that produced electricity out of wind was a good idea. But back then, you know, what they could spin out of a shed was a very small turbine. It only had 10 meters in diameter. That was about, you could fit one of those, kind of the 3 blades here in this room. We've evolved quite a bit since. The way we've made electricity cheap through wind has been by making these turbines fairly big. You'll see why in a second, but our offshore turbine, that's a turbine that we put out in the sea, has 236 meters in diameter. So if you think that we're here on top of this, we would have to look up to really see the dimension of this thing. To give you another perspective, 236 meters in diameter, so the tip of these things makes a circle that's 236 meters. It's about the size of the Porto Stadium. So if you live here in Porto and you walk around the full stadium, that's basically going around the size of these 3 things. To give you another sense of how immense the things we build these days are, is one of these blades is 115 meters long. The largest airplane, commercial airplane in the world, the A380, has 81 meters. So this is just one of these blades is bigger than the largest commercial airplane these days. And this is made as a single piece using the materials you probably know very well, glass fiber, carbon fiber, and mostly that, and made by hand. So imagine a mold that's 115 meters long with technicians rolling out glass fiber. I don't know if you've ever worked with it, but and resins and the whole thing. So we make the largest aerodynamic components on the planet. That's a big statement, right, when we talk about space industry and aircraft and everything, but we, a relatively unknown source of energy, actually make the largest aerodynamic structures on the planet. To give you yet one more perspective about why we are in an energy revolution and why I'm so passionate about this, the Eiffel Tower is 330 meters tall. It took, I think, around 2 years to build. We're getting to a point where we're installing one of these things per week. So we're building roughly the equivalent of an Eiffel Tower per week, and that powers around 20,000 households. I'm going to pause for a second and let that sink. One Eiffel Tower per week, or the closest equivalent. And that's offshore. In onshore, we've been doing this for a long time. Why? And this is, again, back to calling and passion and what gets me out of bed at night. I'm sure you're all familiar with global warming. I don't think it's news, less in this forum. The reason it concerns me personally is my dad was a farmer, is a farmer in his spare time. He's retired now. We have here in Portugal a book called Borda d'Água. It's an almanac that tells you, based on the moon phases and everything, when to plant potatoes, corn, all of those things. That book exists because for the past 10,000 years, humanity has dominated agriculture. That's what forced us to stop being nomads, and that's what led us to be 7 billion people kind of population. Agriculture relies on stable weather patterns. Stable weather patterns don't work when we have an increase in temperature that's unprecedented like this. Now, there's a lot of studies arguing against it, most of them financed, but now I think it is fundamentally an accepted truth that this peak in temperature increases in the planet is human-generated and is associated with CO2 emissions. I don't think anyone's bothering to argue too much against that these days, fortunately. The problem is that, of course, if we don't curb this, then yes, we'll have really bad weather events and disasters. But even worse is we will lose predictable agriculture. We will lose predictable seasons. If we lose predictable seasons, we lose agriculture, we lose food. That's not great, right? It's at least not great to feed 7 billion people. So this is what gets me out of bed in the morning, especially in the bad days when I don't feel like working. What keeps me up at night as an engineer and as a leader in this industry is this. So I've told you that we will be building one wind turbine per week that produces 20,000, that produces power for 20,000 people. We'll do a lot more than that because we also have the onshore turbines. But our slice of the pie is only about 2%. with electricity being around 20% of all the energy consumed in the world. There's a journey where we have 80% of electrification that needs to be done. This is all the cargo ships you see around here. The good news is that we can do it, and there's proof that we can do it. It's also a snowball effect, right? If you start using less fossil fuels, then I think a huge percentage, I don't remember the number, of shipping is container ships, or oil cargo ships. So of course you start needing less of those, and then it's a snowball effect that kind of starts moving this. Electric cars is also another big shift and change. But we need to move really fast. Imagine this is a wave and we're just starting to peak, and we rely a lot on politicians. Now we have some politicians that say that wind is a gimmick. We have others like China, that last year China installed just in wind and solar power the equivalent of all of Japan's electricity production. So imagine this, just think about it for a second. In 1 year, China installed enough solar and wind power to match Japan's full electricity production. The pace at which China has committed to develop renewables, they're still developing coal, they're still developing, and don't get me wrong, I'm not defending the Chinese way of doing things, but they're doing this because China only imports fossil fuels. They don't have oil, they don't have gas, and they know it's a problem for them, so they have a strategy to get out of it. Their strategy is renewables. That's also why you see Chinese cars becoming so popular, electrical cars. In China, they don't call them electrical cars, they call them alternative fuel cars, because it pushes them out of their dependency from externals. What I want to say with this is, of course, China doesn't have the privilege of democracy that slows us down in the rest of the world, but I'm happy to be slowed down. But they are proving that it can be done. They are proving that this is possible. We can actually achieve it. Now, of course, in the Western world, we need permits, we need authorizations, we need environmental studies, we need all these things to happen. In China, they can jump over many of those. But it can be done. We just need to rally up. The best part of it is, and if I go back, is that we can innovate the crap out of it, right? We can dominate this energy transition by innovating a lot. And that's, I think, where the future sits, is instead of pulling back, and this is the last political thing I'll say this morning, or semi-political, is instead of pulling back on the beliefs that the renewable transition can be done, like the US president is doing, because it suits what they have inland, we should, and especially in Europe, where we've always led through innovation, we should be rallying up innovation, because we can innovate through whatever challenge we get thrown at us. And we've proven it. And the Chinese, we've innovated, and the Chinese have copied it to a large extent. But we've proven, and we are proving, that it can be done. And I think that's the important message, and that's what keeps me awake, because it's a huge engineering and industrialization challenge. But at the same time, it's what motivates me as a competitive engineer / business person-ish to go to work every day and to tackle this. Is we can do this, and there's no doubt that we can. And we're seeing increasing proof. I couldn't find it this morning when I was preparing this and last night. Here in Portugal, if you look at the energy mix in 1998 and at the energy mix today, Portugal's already done a huge revolution. In 1998, when the Expo 98 was held, most of the energy produced in Portugal was from coal and combined cycle and hydro. Today, more than 90% of the energy produced, we don't have coal anymore since a few years ago, and most of the electricity is coming purely from renewable sources. So it's not like it's something that's coming, of course, but we have needs that need continuous demand of energy, and of course we need to drive electrification of all the things that don't depend on electricity. Speaking of that, of course, our job at Vestas is to make these little things that spin and produce electricity harnessing wind. But there's a lot that needs to happen, right? We need to increase the penetration of electricity. We need to drive electrification, cars, houses, batteries. We need to drive indirect electrification. That's factories, the construction business, the transport business, the shipping business, all these things that today, the airplane business, that's maybe the most challenging one. And then the most interesting one, for me at least, and maybe the one that is worth pausing a minute on, because we had an infamous blackout here a couple of months ago, is the electrical grid, because that again then depends on politicians, investments, public funds. Energy efficiency. Our grids, even though Portugal has transformed hugely in the last 27 years, our grids remain largely the same. They're operated by some people in a control room, turning some sources of electricity on and off. With all the knowledge we have today, we're still doing things from 30 years ago. We need to improve in how we move our energy systems. And that's a huge challenge. Again, not technical one, but an awareness one. And I think largely that's the issue with sustainability, to maybe bring it around to a circle, is that even though we have repeatedly proven, these are the numbers of electricity prices, cost of energy, so the cost to produce electricity, not what you pay on an energy bill. They're two separate things, unfortunately. You can see wind here onshore, that's my business. It's arguably most of the time, or a lot of the time, one of the cheapest sources of energy. There's no questioning this now. This has been the case for a number of years now. We don't need subsidies from governments or anything like that. It is a cheap source of energy. Now, offshore is a bit more expensive. That's because you have to put the same things in the middle of the sea, and of course, the sea has its challenges. All the conventional generation, hugely uncertain and hugely expensive. Gas can be very cheap, but it's also incredibly volatile. That's where you have the combined cycle down here. Sorry, I was pointing at the wrong place. Nuclear has huge potential, but not in the sense of nuclear plants like you see them today, because they're just too expensive and too complicated to build. Whereas building a wind farm, you know, it is in the middle of the mountains, but the good thing is that you have wind just about everywhere in the globe, and you can actually harness it locally and deploy it to the grid locally. So there's a ton of advantages on that. How am I doing for time? I'm okay. Good, thank you. Okay. But there's still a challenge, right? We still make turbines that are the size of the Eiffel Tower. And those things still use hundreds of tons of steel, and that steel still comes from mills that burn coal or gas to melt that steel. So we have a huge problem. Our turbines, they already offset about 5,000 tons of CO2 per year. Given that a turbine can operate up to 30 years, that's about the size of what 2 blue whales in carbon emissions that a turbine will save per year. Or, you know, if you want to look at that, over its full lifetime, or if you want to look at it differently, we offset the emissions of 1,000 cars per year, just one turbine, an average sized turbine. But they're not carbon neutral. We still use carbon emissions. We still need carbon emissions to build them. We want to change that. That's part of our ambitions. We want to change our turbines. Another thing is, as I'm sure you know, glass fiber that sits in your surfboards, in our blades, is notoriously hard to recycle. Very, very hard. We have a good example from one of our competitors that I'm very jealous of, that have made a campaign to recycle some of their blades into surfboards. I don't know if you've seen that. But we need to create circular turbines in the sense that when they reach the end of life, we can actually disassemble and fully recycle them. We're not there yet, but we're getting there. The biggest challenge has been the blades and the glass fiber, but we've made some huge advancements on that. The other part that's important for us, we are a Danish company and largely European focused, but we employ 30,000 people around the globe. We employ service technicians that will service these turbines in the snow in Finland, in the desert in Kenya, and anywhere in between. We have a huge responsibility to employ locally and have a strong people development, social responsibility to make sure that our employees thrive in their respective locations. That's part of our ambition. It's part of what also we believe will differentiate us in the future from some of our competitors, especially Chinese, that don't necessarily have this level of concerns. And then, of course, as a global market leader that Vestas is, we hope to continue leading this transition into the future. It's already happening. In many cases, it's happened, but there's a long way to go. And we firmly believe in it. So we are really looking forward to continue this journey. And I honestly, this is my personal belief, you know, there's a lot of talk about AI and social networks changing how we live and how we behave. But fundamentally, this is going to mark the biggest shift in the planet. And again, my personal view, the world dynamics today, they are because of the oil industry, right? The wars, all the dynamics you've seen. Of course, when you create energy sources that are sustainable and local, then a lot of countries will lose a lot of their power. And that's what you're starting to kick off some of the shifts you're seeing. So the positive take of this is that we have gone from a subsidized hippie industry to an industry that's now threatening the world dynamics because it is fundamentally changing how the energy markets depend on each other. You've seen this with Russia, we're seeing this with China on the opposite direction. That's, of course, concerning because it's changing the balance of power across the planet. But from my point of view, it's also a sign of optimism that we're actually succeeding to the point that we're now reaching that. Another good example is Norway. Norway is a very, very rich country because they sold a lot of oil. I think that's fair to say. But they've invested it very responsibly. So the Norwegian fund, the largest fund in the world, invests in everything except fossil fuels. And they've basically secured their future for generations to come as one of the richest countries in the world because they've invested that money so well in this transition. So they made a smart bet. And funnily enough, so are pension funds. So I hope there are no dentists here because I always call them, you know, all the dentists that want to save their money in a low-risk place, they're now favoring dentists. I hope you get my analogy. I don't mean it as an offensive term. All the people that have wealth and want to save it for their retirement are now investing in a lot of these projects because they are a very stable investment for the future, because it's just producing low-risk energy for years to come. So it's a very good investment as a whole. I'll wrap up with these 3 points, right? Wind industry, it's not a new thing. I think sometimes people keep calling it a new thing, and it's not. It's been around for a long time. Not as long as surf, but, you know, same scale of time. Understanding wind is really important for us as a business, as it is for anyone else, but the good thing is there is wind everywhere, and we can harness it efficiently. And it is one of the cheapest sources of energy production. I think the other thing I would like you to think about is that a wind turbine will recover its carbon footprint within the first 2-3 years of operation, depending on size or location. And it will pay for itself within the first 5 or 6 years of operation. So it is a sustainable business and a sustainable industry. As a whole, that's what puts us as a heavy industry company always on the top rankings of sustainability indices. It's also a complicated journey, right? Because we're always a little bit at the mercy of political decisions and elections, and of course sometimes it gets frustrating to see that a lot of this is out of our hands. So my personal reflection, and I think it is my personal reflection when it comes to sustainability as a whole, is let's ignore the noise. I think we today with social networks and everything, we spend too much time looking at the noise around the negativity of the world. But if we put our heads down and control our little backyards and what we can impact, then the impact is much more meaningful than we think it is. And I think that's the journey that we're all in, and that's the buy-in that I was looking for you. I hope this was interesting, relevant, somewhat contextualized here. I have time for questions, I think. Yeah? So if you have any questions to the business, to me, to anything, please shoot.